So we're going to call Dr. Fine up here to testify. And the way this hearing will work is we'll start more general, sort of about air pollution, and then we'll go to some very specific studies just on Santa Monica Airport. And so, Dr. Fine, if you want to come up and testify, that'd be great. And one more housekeeping measure. We also will take electronic comments as well. So if any of you want to submit your comments electronically, you can go to air.senate.ca.gov and submit your comments. And also all these studies are on that website as well if you want to link to them and read them for yourself. So Dr. Fine, why don't you go ahead.
Thank you, Senator Liu. I was asked tonight to give a little bit on air quality basics, kind of an air quality 101 course. I'll try to get through it quickly, but I'll try to keep it simple so we can all be on the same page when we talk about the other issues around Santa Monica Airport. Go ahead. So first, again, my name is Philip Fine, and I'm a Planning and Rules Manager at the South Coast Air Quality Management District. And when it comes to air quality, as far as the agencies that oversee air quality, it's a multi-tiered system. We have the federal U.S. Environmental Protection Agency. In the state of California, we have the California Air Resources Board, and then locally, the agency I work for is the South Coast Air Quality Management District. And each tier has different responsibilities when it comes to air quality regulation, control, and cleaning the air. Very quickly, the US EPA sets standards that for ambient air, the concentrations in the air that are deemed to be safe or not safe, and it's up to the states to meet those standards by passing rules and regulations to lower the emissions. In the state of California, some of the authority for regulating those emissions when it comes to stationary sources, which are things like factories, refineries, industrial facilities, has been delegated to the local districts, again, like the South Coast Air Quality Management District. Next slide. So our jurisdiction is basically a four-county area. It includes all of Orange County and the most populated areas of LA, San Bernardino, and Riverside County. But this is the largest local district in the country. It's about 10,000 square miles. We cover 17 million residents, which is probably 1 out of every 18 or 19 people in the country. Includes millions of gasoline vehicles, hundreds of thousands of diesel trucks, and are the biggest port in the country at Long Beach and Los Angeles. Next slide. So why do we have bad air quality in Southern California? You've probably all heard that we do still have very poor air quality. It's a combination of a lot of emissions and a lot of sources, including the trucks and the ships, the cars, the planes, as well as the factories and refineries that we have. But it's also an unfortunate situation geographically that the air pollution gets trapped near the ground under something called an inversion layer. Everyone knows that hot air rises, cool air would stay towards the ground, but when we have an inversion layer with warmer air higher, it basically traps the pollution near the ground, and that's why we have some of the worst air quality in the nation. This isn't just a picture or a theoretical. If you click it, this actually happens, and when you fly in to LA in a plane, you actually see that inversion layer as you're coming in. And you can see this is a pretty smoggy day. Next slide. So just some key air pollution terms. There's basically, you can divide air quality problems into 3 scales. We have global issues when it comes to climate change and greenhouse gases. We have regional air quality issues, which affect areas that are tens to hundreds of miles wide. And then we have local air quality issues, which are those issues that you run into when you live or work very close to a source, up to a mile, sometimes a few hundred feet or a few hundred meters. And each of these scales of pollution air quality problems are handled in very different ways. There is some overlap in the types of pollutants, but they're generally regulated and handled in very different ways. There are many sources of pollution, and we divide those into 3 broad areas. We have the stationary sources I mentioned, which are industrial facilities, power plants, refineries, et cetera. We have area sources, which are spread out even further, things like burning wood in your fireplace, the use of consumer products, agriculture, those are very typical area sources. And then we have the mobile sources, which are cars, trucks, trains, planes, and ships. In general, as a local agency, we have jurisdiction over those stationary sources and some of the area sources, but we do not have jurisdiction over the mobile sources. The regulation of those sources, which cause the majority of our problems, lie with the state or the federal government. Go back one, sorry. And then there's when these pollutants are emitted from those sources, we can divide those kind of into two broad categories. There's certain pollutants that are emitted directly from the source, like from the tailpipe, from a smokestack, and we call those primary emissions. Things like lead, which I'll talk about, particulate matter, air toxics, carbon monoxide, are those directly emitted. Then there's something called secondary pollution, which are certain things are emitted from the tailpipe, and then as they exist in the atmosphere, as they interact with sunlight, as they are transported across long distances and spend time in the air, they undergo chemical reactions and are actually transformed into pollutants that are also harmful. And those things are the two typical ones, and the ones that we are not meeting federal standards for are ozone and particulate matter. Ozone, again, is, you've heard of the ozone layer problem. Ozone in the stratosphere is actually helpful. That is something that protects us from the harmful rays from the sun, the UV rays. But ozone at ground level is actually is a harmful pollutant that we need to lower in order to protect our public health. Next slide. So these key air pollutants, as I mentioned, there's 6 air pollutants that EPA considers what they known as criteria pollutants. You can give it another click. So carbon monoxide, nitrogen dioxide, sulfur dioxide, lead, ozone, and particulate matter. These are the 6 criteria pollutants. The basin is in attainment for the first 3 there. We're in non-attainment for the last 3. The 2 ones we have to work very hard to correct are the particulate matter, PM10 and PM2.5, and I'll explain what those mean, as well as ozone. Next slide. In addition to those criteria pollutants, we also want to protect the public from a category of pollutants called air toxics. And these are specific chemicals in some cases. It also includes lead, even though it's also a criteria pollutant. Certain metals in the air, a lot of organic gases we call volatile organic compounds. And the biggest one is diesel particulate matter, which is that black soot you see coming out of diesel trucks. In addition to air toxics, we're also involved in the greenhouse gases that involved in climate change. And then finally, an emerging issue for us is something known as ultrafine particles. And again, this is an issue at the Santa Monica Airport. These are currently unregulated, but there's a growing body of scientific research that it suggests that these particles have their own toxicity and may be more toxic than what is currently regulated under what's known as particulate matter. Next slide. So just some kind of depictions of how ozone is formed, and you can click through this quickly. Ozone is formed from these precursors. The VOCs, which are the volatile organic compounds, come from consumer products. NOx, nitrogen dioxides, come from trucks. Factories can emit both of those, and cars can also emit both of those, and it all goes into the air. It gets cooked by the sunlight, keep clicking, and over time, click, 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 and eventually it forms ozone. And that gets transported long distances and generally affects the inland areas of the South Coast Basin. Particulate matter similarly undergoes an atmospheric process. It comes from a variety of sources, whether it's on-road sources, factories. Dust also contributes in sea salt. These go into the air, keep clicking, and it also, so those are the primary emissions of particulate matter, but there's also all these other gases that react in the sunlight and add to the particulate matter problem over time. And those form new particles, they grow those particles, and then we end up with particulate matter. Now, particulate matter is regulated based on its size, and what I have here is a picture of if you look at that big gray kind of quarter pie there, that is a cross-section of a human hair. Huh. So that's about what we call 60 microns in diameter. A micron is a thousandth of a millimeter. So the particles we're talking about are very small. 10 microns or less is the big yellow one, and that is regulated by the EPA. The orange one is what we call PM 2.5, also regulated by the EPA. But the ultrafine particle, which you can barely see as a tiny red dot, we're calling it PM 0.1, is what is known as ultrafine particles, very, very small particles. These particles can travel into your lungs, cross the cell walls, get into your cells, and travel throughout your body. And again, there's some emerging evidence that these are harmful beyond the effects that are known for the larger PM particles. Next slide. So where are we now as far as air quality in the basin? This is an example of ozone showing the number of days we exceeded or were above the federal standard. And back in the early 90s, we were exceeding, over 100 times a day. And things have gotten a lot better over time. You can see the number of days we had a problem each year has dropped significantly. And this is at the time where we had very large population growth. So in spite of that growth, we've had great air quality improvements, mostly due to technological advances in motor vehicle emissions, as well as a pretty stringent regulatory program on the stationary sources. But what you also see here is there's, as the EPA looks at the health evidence, that they keep tightening the standard. So as we get better and better, say on that old standard, which is the blue line, they keep making the standard tighter, which means we exceed on more days. So if you look at that top line, that's the newest standard from 2008. And even though it is improving, we still have a long way to go with still over 100 days over the standard. So one distinction I want to make that's important is regional pollution problems versus local pollution problems. So a regional pollutant, like PM or ozone, is generally formed in the air and over hours and days and traveling miles in the air, transported by the wind. Reactions occur because of the sun. Most of these particles or ozone are formed in the air. There are some primary particles, but most of it is what's known as secondary. So these types of pollutants affect large areas and are regulated in a very specific way, but it's a different type of regulation when you have these local air pollution problems like Santa Monica Airport. Next slide. If you see this animation, you'll see how ozone builds up in the basin. And oops, that animation isn't going to work. In any case, if this was working, you'd see over the course of the day how the ozone levels build up inland over Riverside, San Bernardino. They generally don't affect the west side because the pollutants haven't had time to react in the air. So you see it building up in the afternoon with the sunlight over those inland areas, Riverside, San Bernardino, Fontana. Next slide. There was an animation there. Anyway, so when we look at what sources are causing the problem, whether it's PM, whether it's ozone, and even whether it's air toxics, generally over 80 to 90% of the problem comes from mobile sources, and those are sources that at least the local district doesn't have much jurisdiction over. So it's a challenge for us to solve some of these problems when we have limited jurisdiction over the sources causing the problem. Next slide. Now, as opposed to those regional pollutants, when you live close to a source, whether it's an airport, a factory, a freeway, you have a local impact that occurs on, could be 100 meters or a few hundred feet, can extend out to a mile or so. There were a lot of seminal studies done at UCLA on how living next to a roadway increases your exposure to certain pollutants, such as ultrafine particles, black carbon, which is an indicator of diesel particulate, and the closer you are to the freeway, the much higher your concentrations are. So again, whether you live next to a freeway or a factory, proximity matters. On the bottom there is how we do the kind of modeling to show that on kind of a neighborhood scale, the closer you are to a source, the more you are impacted. The types of pollutants that are like this local pollution tend to be called air toxics. However, lead is one of them as well. Ultrafine PM works in this way as well. Next slide. So where do air toxics come from? I mentioned that, click the next, the one that is the most important for us is diesel particulate matter. If you look at the black soot coming out of diesel trucks, that's a very toxic substance as determined by the state of California. It kind of has this look on the right there if you look on it under a microscope. And this really drives our cancer risk from air pollution in the basin. And there are other toxic chemicals that are air toxics. A lot of those organic gases, such as benzene, toluene, a lot of those come from mobile sources. Specific metals, such as lead, are also air toxics. And these are the things that kind of act on that local scale and are controlled at the source rather than controlled by setting a standard for ambient air. Next slide. So just to demonstrate how diesel particulate is one of our major problems, this is from a periodic study we do every 4 to 6 years to look at air toxics throughout the basin. We do a lot of measurements and we do a lot of models that predict what the exposure is and the cancer risk. So this is our final cancer risk map, and you can see that the cancer risk from air toxics in the basin can get as high as 1,000 in a million risk for cancer. Or maybe up to 2,000 in a million in some areas. You can also see how that risk follows the busy roadways and freeways, and in particular the cargo transport routes from the ports are really what drives a lot of this cancer risk because of the diesel trucks, because of the diesel locomotives, and because of the ships. If we take the cancer risk out of this map, next slide, you see the map gets a lot cleaner. Most of the cancer risk goes away. So 80 to 90% of our cancer risk comes from diesel particulate matter. That dot is LAX, and it's a concentrated, there is a lot of activity there on some of the VOCs. That's why it pops up there. But the cancer risk is less than what you'd get with diesel. Next slide. So what are the health impacts of air pollution? And this is not even including air toxics. This is just from PM and in particular, and ozone is similar. We have over 5,000 premature deaths a year from elevated pollution, air pollution in Southern California. And there's a lot of other health impacts besides those premature deaths, including hundreds of thousands of lost work and school days, hospitalizations, the development of asthma and exacerbation of asthma and other respiratory illnesses, the onset of acute bronchitis, and again, the cancer risk that can come from the diesel particulates, other air toxics, and some of the criteria pollutants as well. So with that, I hope that's a good background, and I don't know how we're going to handle questions, but maybe later.
Thank you for that presentation. So I have a few questions for you. Ultrafine particles, who regulates?
Nobody at this point. The only ultrafine regulations are just beginning to take effect in Europe on tailpipe standards for ultrafine particles in Europe.
Okay. And is it possible to say that because of the way the South Coast Basin is constituted that any pollutant effects from Santa Monica Airport would be somewhat magnified because of the inversion layer that you mentioned and the other geographic constraints that we have here?
In Santa Monica, in general, the further you are to the west in the basin, the further you are to the coast, the better your air quality, especially for those regional pollutants. But when you talk about local pollution, it's just how close you are to a particular source. Okay. It doesn't matter whether you live inland or outland. So that's why it's important to draw that distinction. For PM, for ozone, you expect the high levels inland after they've had time in the air to react. For local pollution, doesn't matter you're on the west side, in the Inland Empire, it just matters how close you are to a freeway, an airport, a particular factory, and as you move away, the concentrations drop dramatically. At Santa Monica Airport, that's the situation for ultrafine particles.
Got it. Thank you.
And when you talk about ultrafine particles, you said it's relatively new. Explain how you describe it to be separate from the others. What is it?
Well, I don't know if Professor Foynes is here yet to talk about the health effects. The way EPA sets the criteria pollutant standards is based on hundreds, if not thousands, of studies, epidemiological studies, which look at large populations and long-term exposure and deciding looking at the statistics and trying to tease out a health effect out of that. And there's just not enough information on ultrafines on the epidemiology side yet for EPA to set those types of standards. On the toxicology side, there's been a lot more studies done on ultrafines that suggest they have a higher toxicity. But there's still a lot of unanswered questions about how you regulate how you measure them. It's still an emerging area in many respects.
When a plane, the jets, which are relatively new, 15, 18 years there, when they're idling and the westerlies, that great wind, takes it very close just across a street, are those kinds of ultrafine particles found within the idling jet? Or what particles do you find with an idling jet that might be of interest or of safety or health concerns?
And in my later presentation, when I talk about our studies, I'll get into that a little bit more. But we do know from not only Santa Monica Airport studies, but also studies at other airports, even LAX, that the numbers of ultrafine particles coming out of jets are very, very high. They're very efficient ultrafine particle generators. You can get the typical concentration of ultrafine particles in air, if you went outside right now, might be 5 to 10,000 particles in a sugar cube. Yeah. If you're anywhere near a jet, that can get up to 1 to 5 million. So it's a very efficient generator of ultrafine particles. There haven't been a lot of studies on the relative health impacts of ultrafines from jets versus ultrafines from diesel trucks versus ultrafines from cars. So these are still kind of unanswered questions. But yeah, we have seen very high levels in that neighborhood, and it does travel into the nearby houses from the runway.